Well, welcome, guys. Thank you so much for coming today. We've got a few hours ahead of us where all of you will be learning how to use Kamiak, which is our central computing cluster on campus that was started last year. So for those of you that don't know me, I see lots of new faces. Welcome. My name is Aurora Clark. I'm the director for the Center for Institutional Research Computing. I will be giving part of the Kamiak instruction today, but then a lot of the heavy lifting is going to be done by Peter Mills, who is our computational scientist. Many of you, if you've actually tried to log in to Kamiak or run jobs on Kamiak, you've probably sent emails requesting help. Peter responds to many of those. The other person that will be helping us today for our tutorial is Jeff White, who also should be familiar to many of you. And so I do want to, before we get into kind of the nitty-gritty, and since we just had a big group of people just come in, and hopefully more will come, I want to give our HPC Student Club a chance to introduce themselves. And so, you know, we're working really hard as we have started the Center for Institutional Research Computing to develop a research computing community, and the students play a huge role in that. And so just this spring, we initiated a student high-performance computing club that has both graduate and undergraduate members, and they're really eager to develop, you know, outreach activities and kind of training activities and fun activities for people that might want to participate. And so we have Thomas Badman, who's the president, and then Connor Whitco. Connor, what is your formal position in the HPC club? You need some super-duper title because you do lots of stuff.
Whatever you want to give me right now.
Okay, he's just the super duper undergraduate guy who manages a lot of stuff. So Tom and Connor, can you guys talk a little bit about the HPC Club to people?
I think you're the undergraduate liaison.
Ah, the undergraduate liaison. I like that. That's good. I like super duper better though.
So we're here to represent the HPC Club. It's we meet every few weeks at this point. This semester we have some fun stuff planned. We have representation from a bunch of different departments and a bunch of different people using the Kamiak HPC for different things. I do physics with it. Some people do biology with it. Some people do chemistry with it. Mm-hmm. And some of the fun stuff we have planned for this semester is grad student talks where we'll prepare some stuff that you can actually submit to Kamiak and see how our research works, and some visualization of the results and things like that. And it's got an education focus, so we'll be getting some staff professionals in to actually tell us how to do some complicated stuff. So there's a lot to look forward to with HPC. Oh yeah, we have our own nodes now. We have 3 compute nodes with 24 cores each?
28 cores.
28 cores each.
And the GPU node is somewhere.
It's coming.
The next 2 weeks.
Yeah.
and a big GPU node on the way. So we'll be able to do a lot of stuff, independent research through the club. University of Washington has a similar club that at this point has about 30 publications from just their club alone.
From their club graduates, which is pretty crazy to think about if we could get momentum like that. Also, there's going to be another HPC-esque talk in PACCAR. If you want the details, when you can raise your hand as soon as I'm done talking. And it's involving environmental engineering and the programming language R and how to schedule jobs using R.
So there's another HPC event this week if you're interested still after today.
Why don't you guys write down an email so if people want to sign up and get on your mailing list?
And if you're interested in joining the HPC Club, please email me and I'll put you onto the mailing list. And if you're interested in undergrad related things, you can email Connor.
Okay, so with that, I'm going to turn it over to Jeff, who's going to do an overview of the configuration and setup associated with Kamiak. And then you'll see that Jeff and Peter and I are just going to kind of switch off on things. This is going to be highly interactive. So one thing maybe we want to make sure is that everyone can log in to Kamiak. Everyone should have their laptops out. We're going to actually go through how to log in, but if you already know, then it makes sense to do it now. If you don't, that's fine. Obviously that requires that you have had an account. And so if, as we move forward, you find that you can't log in, don't have an account, raise your hand real high, and then Jeff can help. So Jeff, why don't you take it away with respect to an overview.
And as Aurora mentioned, we're actually going to go over a little bit later at a few slides on how to actually SSH to that. to Kamiak. So before then, once I'm finished talking here, if you actually don't have an account, if you can't get on, just come get to me and I'll get you a temporary account. We'll get you a permanent account later. Okay. So when we're talking about Kamiak, a lot of people really don't understand what it is. What is HPC? What is a research computer? Well, it is basically just that. It's a set of computers all working together to do some sort of a calculation. Together, it's also got plenty of networking to tie all these different computers together, and storage to put your data to store the data these computers will use. So inside Kamiak, if you basically went up to it, you basically just look like you're in any sort of data center from Facebook or Google or anybody else. Just a bunch of computers interact, a bunch of Dell logos on them, nothing real special. What we're seeing up here on the compute nodes, that's essentially what we're talking about. When you're using Kamiak either as a non-investor just coming in, trying out your workload on it, seeing if you can actually use this an HPC resource for your research, or you come in as an investor and actually purchase compute nodes, what you're actually doing is you're just going and purchasing actual compute servers from Dell, putting them into Kamiak, and then you can also purchase storage with those compute nodes or separate from them. So inside of Kamiak, so what I have shown here is that the compute nodes are kind of separated into little kind of sets of compute nodes that we call queues or partitions. Inside Kamiak, it's called partition. If you heard the term of a queue, a compute queue, it's the same thing. It's basically just a set of these compute servers within Kamiak that are owned by a particular person and used by those. So we have a few different examples of that inside Kamiak. We have our initial departmental sponsors who purchased the system to begin with and got the funding to get the pilot system off the ground. So Connors, CAS, and VCEA are those three departments that own a significant portion of Kamiak, and any users that are within those colleges can gain access to those resources. Then we have investor purchases that are from, including Dr. Clark herself, which are just standard compute nodes that their researchers can come and use directly. You'll see later when we talk about the backfill queue, how anybody inside of Kamiak, regardless of whether or not you own those compute resources or you're a member of that lab, you can actually still use those resources if the investor is not currently using them. In addition to the raw compute and raw storage that's within Kamiak, you also have a few other things that we're providing with it. Obviously the university is providing a data center, cooling, power, monitoring, all the other sort of stuff that you need, that we're going to need to actually run this and keep it running for you. Let's go on to the next page. All right, so here's a few basic statistics on what Kamiak has been doing since we rolled it out a little under 2 years ago or so at this point. Been in production over a year at this point.
Just so big.
Yeah, so you can kind of get an idea that we have been having more users coming on board. As you can see through the graph on the right of active users, the CPU hours is basically a measure of how many CPU cores are busy on Kamiak at any given time throughout each month. You can see as we're going forward, we're still growing, becoming a larger resource for anybody to use. Total right now, we have about 2,400 CPU cores and 22 terabytes of memory for use on that. Not any one user can just get on Kamiak and use all of it. There are limitations on Kamiak. Currently, the limitation for the backfill queue is 120 CPUs per user, so it's not exactly one giant machine. One person can come on and just use all of it. It is a shared resource, so if you are using the shared resource of it, like the backfill queue, there are some limitations for how much you actually can use of it. We'll get into that a little bit further as we go on. In addition to the compute that's in Kamiak, the compute's relatively simple to think about. You got CPUs, you got memory, and then you got a high-speed network connecting those nodes with CPU and memory to other nodes with CPU and memory. Fairly straightforward. The storage inside Kamiak is also relatively simple how we have it set up right now. Inside of Kamiak, we have one large NetApp storage array that serves the entire cluster. All use goes to that storage array. Originally, it was also purchased from Connors, CAS, and VCEA as the sponsoring colleges who own another significant portion of that storage. So if you're a member of that college, you also get part of that storage. In addition to these storages that's provided by colleges, investors can come and just like you can buy a compute node or you can use some free, you can do the same thing on Kamiak with storage. You can either lease storage if you need permanent access, year-long, 5-year project, whatever your 3-year, 5-year project. That's an option. We also have free storage that's available on Kamiak that we call scratch storage. Again, we'll show you how to actually utilize that storage Essentially what that is, it's again on the NetApp file system that we have now, just free storage that anybody can use as part of your computations. Although it is temporary, is the only restriction with the free resources as far as storage goes. Okay, so this is showing just kind of a very basic example workflow of how you can kind of utilize HPC and research computing in your work. Obviously, this isn't the be-all, the way to do it. There's various ways that that you can actually utilize this. So this kind of gives you an idea that, the idea is if you're taking something that, maybe you're already doing some sort of computational work, and you're already just doing it on your laptop, you're doing it on a small cluster you have access to somewhere else, then it's relatively simple. The workflow from using Kamiak is relatively simple. You take the work that you're doing on your laptop, convert it into something that will work within Kamiak's scheduler called Slurm, which we'll learn about as well, and kind of continue on just tuning that, making it work well within this particular cluster. If you're looking through the workflow on here, you can kind of see the other parts and pieces that are in Kamiak that were I'll kind of briefly mention a little bit. It's talking about the software modules and submit queues. Basically, what we're going to see here today is as you're working through Kamiak and as you're building onto it, you'll log onto it, you'll see that there's already a lot of resources available to you on Kamiak. There's a lot of software already sitting there. There's a lot of things already there ready for you to use. And that's what this is basically talking about. So when you get onto Kamiak ready to do actually computing, essentially what you do is you take some compute job, some program, let's say Gaussian, for example, that's doing work for you. You take that, put it into a job script. Inside that job script, you load software modules that have Gaussian and any other software you might have necessary for you. Decide what resources you need for your job. Submit your job and resources, meaning number of CPUs, number of megabytes of memory, that sort of thing. Submit it, compute it, process it, do any sort of post-processing on your data, then analyze it and either share it or go back and compute some more. All right. So, in addition to kind of what I mentioned today of what you're actually going to learn about the different kind of pieces of Kamiak and kind of what's involved there, how do you actually use it, and what can you actually do with it, we will be showing you a little bit on kind of standard Linux commands, because Kamiak is just a CentOS server, essentially. It looks like a lot of Linux machines that you may have already been using. Using Ubuntu, it's a little bit different, but basically the same thing under the hood. Although none of you have to be a Linux expert to use HPC, not at all. As you can see, just throughout here, we'll be showing you how to actually load the software modules, how to use the software on Kamiak, how to actually submit a compute job onto Kamiak, and actually show what it does, what does it look like when it's going through the queue into computation, and then giving you your results afterwards. And towards the end, we'll show you some tricks on how to actually get a few things done with Kamiak, how to get your jobs running, and how to basically just be a good user on Kamiak. It is a shared resource. We only have the one machine. There's lots of parts to it. There's lots of compute nodes in there. We're up to about 110 compute nodes at this point, but it is a shared resource, so users, people do have to play together in this sandbox, unfortunately. At the end, we'll also go over a little bit of information on how to invest into Kamiak. If you're already familiar with it and have already been working on it, using backfill or anything else, and you're now interested in maybe going into how you would actually invest in it and continue your usage of it, we'll be able to show you that as well. So before we go on to the next part, and I hand it off on to Peter. Is there any general, or whoever's going next?
I'm going next. That's okay.
Whoever's going next. Is there any general questions on kind of what Kamiak is, what really makes it up? General questions before we move on.
Okay, good. Yeah, I want to also emphasize that if at any point anyone's kind of confused, feel free to wave your hands. I can see through some people, over the tops of the screens. This is kind of a different teaching environment for me. It's kind of neat. I like the fact that every desk has its own set of screens, but feel free to kind of wave your arms around if you have any questions. And so right now we're just going to log on to Kamiak. And so I'm going to show you different ways to log on depending on whether or not you're a Mac or Linux user versus a Windows or PC user. And so because in the previous time we've taught this introduction class, we found that we had a really broad distribution of backgrounds. And so we want to make sure that everyone's covered that way. And so for those of you that are first using a Linux or a Mac, we're going to use something called Secure Shell Protocol to log in. And the login is just going to be hopefully everyone has thus far requested an account. And the account that you have is validated through the Active Directory. So it's just your normal email Active Directory account that you have. And the extension is going to be at kamiak.u.wsu.edu. And so, for example, if you're on a Mac, you'll go under Applications, Utilities, Terminal, because the terminal is what you're going to open up to log on to Kamiak. And then you'll just, so this is an example of the terminal that I pulled up on my Mac. Oops. And then from this, you would then type SSH, your name, at kamiak.wsu.edu. And so, in fact, I can do this right now. SSH AU Clark at kamiak.wsu.edu. A lot of times it's the first time that you've logged in from a machine. It'll ask you if you're sure that you want to continue connecting because it uses these authentication keys. So I'll type yes. Now I'm going to put in my password. And there I'm logged on. So that's the example of how you would do this through Mac. Now, if you're going to go through a Windows-based machine, you need to install software like PuTTY or MOBA Xterm or Cygwin to mimic what we call the X-terminal environment associated with the Linux or Unix workstation. And so we're going to go through the example with PuTTY, because PuTTY is probably the easiest software to install this way. And a lot of this stuff was covered in the emails that were sent to everyone who registered. Make sure that you've got PuTTY on your machine if you're a Windows user, but we want to make sure that everyone's kind of on the same page. So you open up your PuTTY, you click on it, and it'll open up what's called a configuration file. It'll ask you for your host name or IP address. So again, you're just going to put in your username at kamiak.wsu.edu, and then you click the open button. And it'll ask you, it'll open, so you'll see that this PuTTY terminal looks an awful lot like your Linux terminal or X terminal that I just opened on my Mac. And then you'll put in your password, and then you'll be done. So let's make sure, if you have not, we're not able to just log in right now onto Kamiak, raise your hand so that Jeff can kind of go through and help. I see Doug needs some help. There are a couple other people. So we'll make sure that you guys, while you're talking real fast and kind of making sure people are on, I'm going to go through just kind of a brief review of some basic Linux commands. And so for those of you that haven't gotten a chance to log in yet, just wait for Jeff to kind of help you out a little bit. But nothing here is super critical. So when you think about Linux as an operating system, the main difference between it and Windows is that there's no graphical interface. You know, you're used to clicking on a button that has an icon and it opens up a directory and you see all the files in the directory. And so instead, Linux is based on something which is called a command line prompt. So all of your commands that you type in commands into a prompt and it will do the things that you want it to do. So you can, for example, type ls, which stands for list. And in fact, here's an example of list. I'm logged on to the cluster right now. I type ls. I see all these files that I have. And you'll notice that there's actually color coding associated with if you have things that might be directories or zipped files versus unzipped files. Executables might have a different color. There's actually a really large amount of configuration that you yourself can set up as a user associated with what are called your environmental variables. And so as you become a more experienced user, you can tweak those environmental variables to make it a little bit easier for you to navigate. A lot of times when people just log on, everything may just be the same color, which means that you need to kind of keep track of this is a folder, this is a text file, etc. So list is one of the most common kinds of commands that you're going to use. Another really common command is the copy command, and we're going to actually go through examples using the copy command where we're going to move files onto your home directory that we're going to use in this tutorial. CD is another very common Linux command, which stands for change directory. And so you'll notice that a lot of these commands actually are just acronyms from the actual what you want it to do. PWD stands for present working directory, and it will tell you where you're actually located in your directory tree. So all of this was in chapter 2 of the tutorial that was sent out over email. And so there are also some shortcuts or appendages to these commands that you'll often see and you should be thinking about. For example, there are shortcuts like cd space ... means that you're going to go up a directory as opposed to down a directory. you can actually type what's called the explicit path of the directory if you want to go into that. And so this will, for example, cd/test changes you directly into text and into the folder called text. And so there are lots and lots of tutorials, and really the key thing here is just lots of practice to make sure that you're kind of using those commands. For the purposes of today, we're going to go through every single command you're going to use, so it's not like you have to memorize any of them, but really familiarity will help you a lot through practice. The other major component associated with just with being able to use Kamiak is presumably, you know, obviously when you log on to Kamiak, you're going to want to move things or list files or open directories, etc. But you also may want to open files themselves. And so just like there's no you know, graphical interface for where folders and directories are, you have to choose a text editor. And a lot of us are used to using Word, which is solely a graphical-based text editor. But you have to choose a text editor to edit files. So you open a file up, you want to edit it, you want to save it, you want to close it. And so the most common text editor software that is employed on Kamiak is called Vim. Vim is, I would say, it takes quite a bit of practice to be good at Vim or VI. However, I would argue that Vim probably has the broadest amount of utility. It allows you to do really phenomenal amounts of text editing within it. But there's a number of other ones that perhaps have a lower activation barrier for learning. Emacs is one that a lot of people use, as well as Nano. And so there's lots of different text editors available to you on Kamiak, and you just need to work through those tutorials associated with them. For the purpose of today, you're going to do a really minimal amount of text editing in any folders. You might use VI to open one up, but you're not going to be doing a lot of manipulation. And so the purpose of this workshop today isn't so much to teach you about, you know, practicing Linux commands and practicing text editors. It's more to get you doing kind of practical work. But I would really encourage you to choose a text editor and work through tutorials and just kind of gain that familiarity. So once you log on to Kamiak, one of the first things you need to do is actually transfer files onto it. Presumably, you're not going to create all of your input files from scratch for a given calculation. A lot of you may have data that's stored on your local desktop and you want to move it over. And so the first thing we're going to practice is actually moving files onto Kamiak into your home directory. And so we're going to first, I need you to look onto your desktop on your laptop that you have open and find a file that you wouldn't mind having transferred onto Kamiak. Take a note of its name. Okay, I'm going to move a file called test.com off of my desktop, and using either your terminal from the X terminal from your Mac, or we're going to go through another example using WinSCP. So we're going to do both examples just like we did with logging on. And so the first thing that I'm going to do is I'm going to show you guys how to do this for a Mac. So I'm going to have a source file that's on my desktop, and then I'm going to move it onto my home directory on Kamiak. And you'll notice that the home directory is actually indicated by a tilde backslash. So that always means go to that, put that in my home directory. And so I'm going to open this right now. I happen to have, actually, I don't think that I'm going to log out because I was just logged in. So I'm going to type exit. If you type exit, that logs you out of Kamiak. So everyone should type exit so that they're logged off. And now they're going to move a file from their desktop onto Kamiak. And so I'm going to actually, I'm going to cheat right here because this is not my laptop. So I'm going to create a little file called test.com. So I just made a file called test.com, and you can see I just typed ls, and I'm actually on my desktop on this Mac laptop, and I can see everything that's on my desktop. And on my desktop is now a file called test.com. Now I'm going to type SCP, which stands for secure copy. So we're going to, when you do these copies and when you log on, you use secure protocols to do this. So I'm going to type SCP, which stands for secure copy, and I'm going to move test.com onto my home directory on Kamiak. So I'm going to type in my username at kamiak.wsu.edu, and then I'm going to use a colon, tilde, backslash. And this is the path of where I am putting this file. I'm just putting it on my home directory, so the path is just tilde backslash. Now I'm going to hit return. It's going to ask me for my password because when I copy a file over, basically I'm logging on to Kamiak and saying I'm giving Kamiak permission to put this file on my account. So I'm going to type in my password. And now you'll see it says here, test.com, 100%. There was actually nothing in this file. I just created an empty file so that there was nothing to transfer. So that's why it says 0 kilobytes per second, because it was empty. But if I type ls now, oh, actually, so now if I want to see this, I want to see on Kamiak where I put it, I'm going to log back into Kamiak, SSH auclark@kamiak.wsu.edu. I'm going to type in my password, and I'm going to type ls, and there, right here, is the test.com file that I just copied over. So everyone who's on a Mac, I want you to try and go through that process. If you have a hard time, raise your hand, okay? Because it's really important. We're going to practice some copies, and this is not the first, this is just the first one. You're going to do lots. So if you have a problem, raise your hand, and Peter and Jeff are going to go around and make sure everybody's okay. I'm now going to cover this for people that have Windows machines, okay? In the case of a Windows machine, the example that I have here is for a software program called WinSCP. So this is a Windows Secure Copy program or software program, and it's going to use, you'll see that there's a file protocol button right here, and you can choose the protocol. You can do Secure File Transfer Protocol, which stands for SFTP. This also opens up, if you drop down this, I don't have it on this because this is a Mac, but if you push that button, you'll see that there's a series of protocols. And again, it'll ask you for your host name. You'll type that in, and then it'll say that it's searching for the host. It'll ask you for your password. So you'll again put in your password. Then it'll open up this really nice graphical interface where you can actually see folders and directories. And so this is just a matter then of dragging files back and forth. Or if you right click on one, you can actually download or upload a file. And you have that utility to be able to do that. So you can either click and drag or right click on it and move it over. All right? So now what we want to do, has everyone been able to do their test file? Because we're going to get ready to actually transfer files that we need from this workshop, which is actually going to be on Kamiak, moving files between different places on Kamiak. But I want you guys to all go through the example of doing it first from your desktop to Kamiak itself. So I'll give you guys a couple minutes to do that. I'm going to go back and have my little cheat sheet here that shows you about how I did this for the Mac system using the SCP command line.
Do we need to log out Kamiak every time you transfer some file?
If you want to so no, you can also do the reverse where you're on Kamiak and you're going out to a place to pull it in. But there you need to know like the IP address of your desktop, for example. If you have a fixed IP address or you're on a desktop that has a name, you can totally go in and do it from Kamiak. But it depends a lot of times in this environment on a wireless, you're on a dynamic IP, so it's a little bit harder to do. But if you have a desktop that has a specific name, you can be logged on to Kamiak and do SCP. So actually, let me show you that's an excellent question. So the question was, do you have to log out all the time? So let us say that I'm on Kamiak and I want to go get a file from a desktop. And my desktop has a fixed IP address or it has a name associated with it. I can actually do that. So, and I'm doing it just kind of in the reverse. So I'm going to do SCP, and I'm going to choose a desktop that's from my own lab. They're all really easy to name because they're all named after flowers. So I'm going to go, let's see, what's a good one? I think lilac. Let's see if this one is on. So I'll type in the name. This is the name of one of the desktops of one of my students in my lab. And so this is the name of that computer, and then I'm going to put in the path. And actually, I'm going to put my username in here. So I'm going to put auclark so this is on my account on my student's desktop. And then : / meaning from my home directory. Okay. And I don't know if this file exists, but I'll also try test.com. So I'm saying, okay, I want this file. It's going to be under my directory on my account on my student's desktop. It's on my home directory, and it's called test.com. And then I'm pulling it back to my home directory on Kamiak. So I'm going to put a dot there. When you put a dot there, it means your present working directory, basically. So right now on Kamiak, I'm located in my home directory. So I'm saying, go out there, get this file, pull it back to my present working directory. And that's how you would do that. Excellent question. Any other questions about copies between remote locations? Okay. So let's try now to copy the files. Everyone needs to log back onto Kamiak. And we're going to transfer the files that we need for this actual workshop into your home directory. So I'm going to log out. I'm going to log in now, just like all you guys should have logged out. Now you're logging back in. I'm logging in. Put in my password. Now I'm logged back in. And now I need to transfer the files that we're going to be using in this tutorial. Okay, so first thing, let's make sure you're in your home directory. If you just type CD, it automatically reorients you if you've accidentally gotten into some subdirectories. It will automatically put you in your home directory. And we want to do that first because that's where we're going to put these files. So just type CD. And now we want to copy an entire directory. We've made a directory in a folder called opt apps samples training. That is the name of the directory. It exists in a directory tree called /opt apps samples. And we want to copy this entire training directory onto your home directory so that you can then go into that directory and we'll open files and we'll use them when we submit jobs today in this practice. So to copy a directory and all of its contents, we want to do it what's called recursively. So recursively means that it's going to go into a directory and get all the contents inside of a directory. So we'll do scp-r, so for recursive. Then we're going to put the path of the directory that we want to copy, which is /opt apps samples training. And you'll notice that I don't put a trailing slash here, and this actually is really important. And when we do these copies, you'll see why. And that's because I want to copy the entire directory, including the directory name itself. So I want to have a folder when I'm done that's actually called training, and in training will be all these files. And then I'm going to put the dot there to mean put it in my present working directory. So all of you guys should be in your home directory. You'll type scp-r/op/app/samples/training space dot. I can just do this -r opt apps samples training dot. And it copied it all over there. And now if I type ls, I now have a folder called training. Great. So you'll notice that these Linux commands, they do, the benefit and detriment of computers is they do exactly what you tell them to do. And so if you're missing any space, it's really, really common to have very small typos. So for example, if you're missing a space here, or you have any of this type wrong, or you don't have a space here, it's really important, this dot, because then you're telling it where you're putting that file or that directory. So the devil is in the details with respect to kind of working in a Linux environment. It's a lot easier to make a lot of small mistakes. So just be patient with yourself. It's really easy to get frustrated, and just keep on practicing and it'll be okay. Okay, so does everyone now should have this training directory? Now so I'm showing you what happens when I do it. So I did scp-r, I pulled this training directory into my present working directory. I typed ls so that I can list the folders and files that are in my home account. And you'll see that I have this new directory now that is copied into my home directory. Now, you'll notice, remember I mentioned this trailing slash at the end of the word training. Because you're on Kamiak, and I was copying a folder from one place on Kamiak to another, I could have also just used CP. So they both work. I was just trying to be kind of consistent for people. Okay, so now if I had typed SCP, the -r and then this guy, and I'd put a slash here, right there, what it would have happened is something very different. Instead of getting a directory that had the word training on it and inside all the files, I would have just gotten all the files, and I would have gotten the directory itself. And so it's actually kind of a pain, because if you have trust me, with the trailing slash, if you have hundreds or thousands of files in a directory and you're trying to copy a directory and you do that, you'll just get overwhelmed. With me and my own research, we frequently have directories that have tens of thousands of files in them, and there's nothing worse than when you do that. So trust me, it's just something to kind of pay attention to. So now, if you type, actually, I'd like for you guys, if we, here, I'm gonna go and you can type ls training, you'll notice that and you can actually type the word training in backslash, or you can type TRAI and hit the tab and it'll fill it in for you, which is what I just did. You'll see that there's a whole suite of files in this training directory that we're going to be using during the course of the training today. So all of you guys should see that. So the other type of copying that we can do is a little bit different than just copying a folder or file a single time. We can use an entirely different type of copying protocol called rsync. And rsync is actually really useful. To my knowledge, rsync only works if you have a Linux or a Mac. But what's useful about rsync is if you have to transfer a lot of data, and maybe you have to do it multiple times. Say you're trying to do updates to a bunch of files, or you've made a modification to a bunch of files and you want to copy them all over, but you don't want to have to pick out individual files. You just want to put the whole directory there. You can use rsync, and what rsync does is it's a software program that actually compares the differences between the contents of two directories. So if I have a directory on my desktop, on my laptop, and say it has 20 files in it, and I've edited 2 or 3 of them, and I don't want to have to pick those files out and just copy them individually, I can use the rsync, and I've already copied this directory onto Kamiak. I can use the rsync command, and what it will do is it'll compare the contents of the directory that's on Kamiak and the directory that's on my desktop. It'll only move the ones that are different. So if you have lots of data that you're moving, this is actually super handy. This also provides a way, like say you were doing backups of your data onto a remote location. Like maybe you've got a server in your office or lab space and you want to do backups of your data that's on Kamiak. But you don't want to copy all of the data all the time. You only want to copy the data that's been changed. You can use the rsync command. And so you'll notice that there are lots of options, just like in the SCP case that I showed you the option, the -R option, which meant recursive. You can also there's also options for rsync. And in fact, it might be useful for you guys. I'm going to show you my Kamiak window here. If you're ever curious about what the options are to go after a command, you can type man for manual and then the name of that command. So I'm going to type man scp. And what it will show me is all of the commands that could potentially go after scp to modify this command. So we use -R for recursive. And you can use your little arrow button to scroll down and it'll tell you what all these options mean. So you can tell it to limit the bandwidth and the amount of transfer. You can tell it all sorts of interesting things. And there's actually quite a lot of options for SCP. Here's the recursive one that I just showed you guys. Recursively copy an entire directory. So now you'll notice that on the bottom here it says manual page for SCP line 118, press H for help or Q for quit. So I'm going to type quit and it automatically exited me out of those manual pages. So the manual page for rsync, I've shown you what some of those options are on this slide right here. So here's an example of rsync. So let us say I want to copy data again from my local computer to my home directory on Kamiak. I'm going to use rsync. Here's the rsync command. -AVZ means archive, verbose, and compress. So when it transfers this data from my desktop onto Kamiak, it'll create an archive, which is just a file that tells me what's in there. It'll do it verbosely, so if there's any errors, it'll spit out the errors to me. And it'll compress it into like a gzipped type of zipped directory. So again, just like before, here's my test file. Again, here's my name at kamiak.wsu.edu. And here's the path that says what my home directory is, that ~. So rsync can be super useful. We're not going to practice it much today. But if you do have a situation where you're running backups regularly, or you have a big directory and you just changed a few files and you don't want to pull out the individual files and move them on to Kamiak, rsync can be super useful. So that's all I'm going to say about rsync. Okay, so here's just me showing you how I've used it. I'm not online logging in dynamically this, but you can see I did my rsync, I did this, it asks for my password again, it builds the archive file list, it moves the directory, it tells you how much it moved, etc. Now again, I want to show you this trailing slash business versus non-trailing slash. Here's an example here where I'm using rsync to move a directory called codes and scripts onto my account on Kamiak. But here I use the trailing slash, which means it's not going to create the folder codes and scripts. It's just going to move all the files inside onto my home directory. So from this little bit, everyone should be logged on to Kamiak. Everyone should have at least thought about their text editor. You've at least gotten some information there. You've gotten a little bit of information about your basic commands to navigate directories and moving files. You should all have the training directory in your home directory on Kamiak. And so now Peter's going to take over, and Peter's going to talk about how the actual job submission works. We're going to go through lots of examples of submitting jobs, how the queue works, etc. Okay? Are there any questions at this point before we move on to job submission, or anybody who's having a problem, raise your hand so that we can go around. Awesome. Okay. Oh, yes.
Is there like anything called undo in this whole business?
Ah, that's a very good question. So if it is just a simple, like say you've copied a directory or something like this, not a deletion. If it's not a deletion, then generally no. However, it is true that Kamiak, we employ what's called, I guess you're calling it snapshots. We call it snapshots. So Kamiak regularly takes snapshots of everyone's home directories. And so if you had a file there, say that was really important to you yesterday, so they're done once a day. So provided you didn't just make it, provided it was there a day ago, if you accidentally delete a file, then you can recover that file. A lot of times what I would encourage people to do, and this is something that you can set up in your environmental variables, until you're a really good user, the default settings typically ask you if you want to delete a file and say, are you sure you want to delete this file so that you don't accidentally get in trouble? It doesn't typically do that for copies or moving things around. However, if you really want to force it to, you can by changing your environmental variables.